Hi, everyone. Thanks for joining today's session on migrating to Datadog, co-hosted by Datadog and NoBS, a premier Datadog partner. What's about to happen is we're going to cover about 40 minutes of content, and then we'll wrap up with live Q&A. So you can drop any of your questions throughout today's session in the Q&A section at the bottom of your screen. We are recording today's session. You'll have access to this and all the slideware after in the follow-up email. So with that, let's get started and hand things over to Kevin and Nick for some intros and all the great content.
Cool. Thanks, Jess. Hey, everyone. My name is Kevin Golterman. I'm a partner solutions engineer here at Datadog. I've been with Datadog for just under 4 years now. First 2 years, I was a technical support engineer and then switched over to my current role just under 2 years ago. Been working with NoBS for, I don't know, probably just under a year now. And yeah, with that, I'll pass it to Nick.
Thanks, Kevin. Hey, everyone. Thanks for joining us today. My name is Nick Vichelio, the principal engineer and co-founder of NoBS. I've been working with Datadog for well over 10 years at this point, and I actually got my start with it by doing migrations of 7 or 8 platforms over into Datadog. Just a little bit about NoBS. We are a consulting and professional services company that is fully dedicated to Datadog and everything surrounding it, of course, including cloud work, automation, observability, best practices, and anything related to Datadog and the usage of it. That being said, a lot of the work that we do winds up being migrations. So let's get into it without further ado. The first thing that we should talk about in terms of migrations is the challenge behind it. It's a little bit of a hard truth. Migrating observability platforms is not like migrating other pieces of software, like a ticketing system or something like that. We can't just export our data from one place and put it into the other and call it done. We need to approach a migration like a translation exercise, trying to recreate exactly what you had before in a previous platform. You're going to kind of end up with the worst of both worlds. There's a lot of pieces of software out there that have been in the observability space for a long time that encourage paradigms that work for that platform, but do not work with Datadog. So you wind up following that paradigm in Datadog, and you get an implementation that can feel awkward or deliver less value than what Datadog is capable of if you had designed your migration to work with Datadog in the first place. So let's look at some of the fundamental differences between Datadog and some other legacy platforms.
Cool. So kind of when we look at what makes Datadog different, we see 3 fundamental differences that help differentiate Datadog from the legacy platforms. First, we're going to be looking at the organization model. So many other legacy platforms tend to organize everything around applications or business transactions. Instead, with Datadog, we're going to organize around services using 3 core tags. You'll hear me say this a couple times in the next 40 minutes, but those 3 core tags are going to be environment, service, and version. And this isn't just naming, it's a fundamentally different approach to the correlation. So when you look inside the actual Datadog platform, these 3 tags are automatically connecting your infrastructure metrics, your traces, your logs, and your RUM data, all allowing you to navigate between these products and make troubleshooting that much easier. Second, we have the metrics first approach. So when you look at competitor models, they often emphasize trace retention, meaning keep everything, query later. With Datadog, we generate metrics from all traces, whether they're sampled or not. So this means you get complete statistical data for your dashboards, alerting, without having to retain every single span, and build up that cost. So without this feature that we see in Datadog, teams can either over-retain and spend too much or underutilize the metrics and miss their insights. And third, we have correlation is tag-based rather than configuration-based. So in the legacy platforms, you often have to explicitly configure how these things connect. With Datadog, if your tags are consistent, then that correlation is just going to work. So, it's important when looking at this migration, getting set up. If your tags are inconsistent, no amount of configuration is going to fix it, or it's going to be, quite the headache.
So when we look at how we can execute a migration, there's plenty of ways to go about it, but there's three primary execution models that we see. We have phased, big bang, and hybrid. A phased execution model, we're looking for one area at a time with validation and then proceeding from there. A lot of times, what we see in this model is we pick certain business segments or certain groups of applications that all fundamentally work together, instrument them so they're all talking with each other and all the data is connected, creating the dashboards, monitors, and other resources that are required for it. This is a pretty well suited method for large environments that are risk averse or have complications in whatever may occur there. So we can take one important business area at a time and make sure that everything is migrated to its full extent and that we've validated everything along the way. There's also the Big Bang method. This is a much shorter turnaround because that's exactly what you would expect it to be. There's a lot of planning involved. You execute very rapidly, and then there's just kind of a cutover one day. This works well for kind of smaller to medium type enterprises with a strong team, and not even just a strong team, but strong automation. When I did the initial rollout of Datadog at Wayfair, we went big bang. We had a lot of planning in the background. We did a little bit of work in the dev environment to make sure that our integrations were up and running and reporting data, that we had coverage across everything that was important. And then we made a push to production. And over the course of an hour or two, we watched Puppet roll out the agent and all of its integrations to 35,000 servers. And from there on out, we were in Datadog and we phased out the rest of the observability over the course of the next few days and weeks. There's also the hybrid approach. So this is where we can take a little bit of the best of both worlds here. We can have multiple groups working in multiple departments. We can take the time to learn what works for certain teams and what doesn't, apply those models, and then approach things from different criticality. So in the hybrid sort of thing, it's really just it should still be a planned migration, of course, but we have teams that are working a bit more independently. We may be working through different types of automation. We may be working through different types of business requirements, but we can do all of this in parallel to have the migration become successful over like a medium term period of time where priorities are dependent on what is critical to each and every individual team. And of course, there's plenty of other models that we can work through here, but this is what we see most commonly.
Cool. So looking at our migrations, we often see, common trends throughout these. And so from those over hundreds, maybe thousands of migrations, we pulled out these 10 migration principles. So these aren't just theoretical. From a Datadog point of view, these are lessons we've learned watching teams both succeed and fail. So there's 10 of these. Stick with me here. Principle one, if it's not going to be a one-to-one translation, or sorry, it's not going to be a one-to-one translation, right? These are different platforms. You're going from one to another. It's not going to be an exact copy. So when we're going to Datadog, we need to reimagine the information that we're bringing in. Principle two, tagging strategy before everything. Like I mentioned, unified service tagging must be one of the first implementation decisions that the team makes. Every subsequent decision, dashboards, alerts, cost allocation, access control, all this depends on consistent tagging. Like I mentioned before, retrofitting these tags later is going to be exponentially harder than getting them right initially. Number three is going to be infrastructure first, always. So deploy agents and establish that baseline infrastructure monitoring before APM, before logs, before anything else. Infrastructure monitoring provides that context layer that makes everything a little bit more meaningful down the road. Principle four is going to be parallel operation. So you're never going to cut over on day one, right? That's obviously just not going to be a safe approach. So we're going to run parallel for at least 4 to 6 weeks. Nick might have some better input in that, but this isn't just about trust. It's more about validation. So you need to confirm that what you're seeing in Datadog matches your reality and the information that you are used to. Principle five, measure twice, alert once. I know Nick is a woodworker, and I'm sure this is burned into his brain here. Your old alerting configuration is most likely going to be wrong. So Most organizations have significant alert fatigue. Their SREs get pinged at 2 a.m. They wake up, they see it, go back to sleep. So migration is your opportunity to implement that proper alert hygiene. Fewer alerts, make them all actionable, properly routed to the correct people. Principle 6, logs are a cost decision. So it's not going to be smart to index every log at full retention. That's not necessary, and it's going to explode your cost beyond what you are expecting. So before collecting a single log, we're going to decide, what do I need to alert on? What do I need to query frequently? What do I need for compliance? Everything else is just going to be cost without value. Principle 7 is going to be APM sampling. APM sampling is going to be your friend here. So with Datadog, you have intelligent retention, which captures representative traces automatically, and then custom retention filters are going to be for those specific use cases. If you're not retaining 100% of your traces, you're likely spending more than you, sorry, if you are retaining 100% of your traces, you're probably spending more than you actually need to. Principle 8, the service catalog is not optional. So this is going to help drive ownership, which drives accountability, which ultimately drives that operational excellence that we're going for. If you don't know who owns a service, you can't route those alerts correctly or attribute the cost that you might need to. Principle 9, migration is a journey, right? So we're going to plan 6 to 18 months, depending on the scale there. And rushing that time frame is going to create that technical debt that you're going to have to deal with down the road. So the goal is to migrate once and not migrate fast. Lastly, we have principle 10. So success requires organizational change. Getting teams to use the new platform effectively is going to require training, enablement, champions within each team. So you need to make sure we're going to budget time for this. And make sure that this is, part of the process here.
Awesome. Thanks, Kevin. I think there's something that I say very, very frequently when it comes to migrations, to the point where I'm probably going to have a t-shirt made about it at some point. But we can take pretty much all of these points and boil it down to that statement. And when you're thinking about moving from your house or apartment to a new house or a new apartment, when you pack up everything on the moving truck, do you pack up the trash that you were going to leave and take it with you, or do you leave it at the curb? Of course, we're going to leave it at the curb, right? And we're not going to bring our old stuff with us that we're going to throw out. And then when you get to your new place and you're starting to unload the moving truck, do you set up your living room in the same exact way that you had it before? Or do you fit your furniture to the new space that you're in? And we can think about that with migrations. We want to rethink what we're doing and what we're actually bringing over, like what we've talked about a few times already. And then we need to rethink everything. It's going to be our new space that we're moving our sofa into. So with that being said, we can go into the migration framework. This is, as much as it looks linear on the screen right now, this doesn't necessarily need to be linear after a certain point. Phase 1 and 2, absolutely linear. Phase 1 being discovery. We could also call that planning. This is where we start to look through our current platform or platforms, decide what it is we're actually using, what is it we actually care about, what do we actually need to bring over, and then planning for your tagging strategy. The next part is the foundation. On the last slide, Kevin mentioned that infrastructure first always. A big part about that is the infrastructure agent, the Datadog agent that runs on all your machines. That's responsible for collecting your traces and your logs and running additional integrations. If you don't have that in place, you're not going to be able to get the rest of the bells and whistles that the agent can provide and the rest of the value that it can provide. Phase 3 and 4, this is where the linear side of things could potentially break apart. You definitely don't have to do APM before logs. You can do logs before APM. You can do logs and APM at the same time. If your automation is built out well enough, you can collect logs as you install the infrastructure agent. But it is worth thinking about these things independently, which is why we have them broken out into different phases. So Kevin mentioned the APM sampling and service catalog and ownership. That's a big part of that. And a big part of logs is, it is a cost decision. At the end of the day, logs can be not even just a huge cost burden, but if we're talking about the signal to noise ratio that they produce, Are we producing accurate data? Does it actually tell us anything? And is it collected properly in the first place? This is a really good time to evaluate what it is you're logging and what it is you actually care about and utilize, and rethink that as well. And then phase 5 is the operational side of things. So this is largely considered the point where we start to take all the data that we've collected and start utilizing it in terms of creating dashboards, monitors, SLOs, synthetic tests, all the rest of the stuff that's in platform in Datadog. A lot of that should be part of the rest of the migration here as you install integrations and agents and cloud configurations. You'll get a lot of dashboards that are out of the box, but the operational part of things is where you start customizing those to your needs, tuning your alerts, making sure that notifications are all buttoned up, and actually start utilizing the platform in its entirety. So let's talk about a bit of our key mindset shift here. We've said this a few times already. Don't translate, reimagine. This is the most important thing to consider as we're going through a migration process. Your existing observability setup has evolved over years on a different platform, trying different capabilities and limitations. If you've had certain platforms for multiple years, you've had people join the company, leave the company, rethink how they're alerting and creating dashboards. And a lot of times those things aren't cleaned up. A lot of times they're not questioned. People start to create email filters in their inbox to start routing certain alerts, or all alerts, unfortunately, in some cases, to another folder or directly to their trash can and everything. So trying to recreate exactly what you currently have in any given platform, you might be trying to migrate things that were built for 2016 capabilities, and it is currently 2026. So we need to really rethink exactly what it is we're doing and how can we be most efficient. So the question shouldn't be, how do I recreate my dashboards from product XYZ in Datadog? The question is, what do I actually need to know about, and what's the best way to do that in Datadog? And this is why we recommend discovery before implementation. You really need to take a step back and think about what you're actually trying to achieve, not just copy exactly what you already have. We can go a little deeper into each one of these phases here. So phase 1 being discovery and planning. This can take anywhere from 4 to 8 weeks on a general basis. Sometimes it's faster, sometimes it's a little bit longer. It all depends on size, complexity, sprawl, and all of those factors. So get general guideline of 4 to 6 weeks. But the goal here winds up being to create a complete inventory, establish your tagging, and build out the rest of the project plan here. We need that plan because before you can understand where you're going, you have to understand exactly where you are. This has to be thorough. Having shortcuts during this process creates problems that compound throughout the rest of the migration, and then ultimately leave you at the end of it with potentially less than you desired. So we need to start thinking about things like the infrastructure inventory. How many hosts do we have, and how many are Windows versus Linux, and are they in the cloud, and or which cloud? Are we still running them on-prem? Do we have a full inventory of everything that we need to monitor that's critical for our business? Are we running Kubernetes? Are we running Docker Swarm? Are we running serverless functions? What are our databases, and where are they? Are we thinking about managed services versus self-hosted? So we really need to think about everything that is critical for us and make sure that we account for it in the planning process here. We also need to take a look at our application inventory. So things like, how many services are we running, and what do those services, how do those services kind of combine together to make an application? So an example that I would typically use here when defining a service versus an application, this is how we think about it when we do migrations. If you're running a retail site, you would have a storefront, is where your customers go. So the application would be the storefront, and that's made up of the cart API, the product API, the customer API, address API, so on and so forth. Those are all individual services that make up the storefront application. But we need to break this down in terms of what languages are being used to develop these. How are they deployed? What dependencies do they have? What is currently instrumented versus what is not? And then we need to look at the existing configuration, and not to translate it, but to understand it. How many dashboards exist, and how many are actually used? How many alerts were fired that were actively ignored, or don't contain runbooks, or don't actually tell you when there's an issue and are just there for some sort of signal that somebody cared about once upon a time? What logs are collected and what's the actual query pattern utilization of these? And do they provide value when you're looking into an issue? So that's going to be our discovery and planning phase. And then we get into tagging strategy and design.
Awesome. So if you haven't heard me say this enough, hopefully this solidifies it. But tagging strategy is going to be one of the most critical decisions you'll make in your discovery. So, like I've mentioned a couple times now, this strategy is going to affect every subsequent decision and cannot be easily changed later. Can be down the road, but much harder to do it down the road instead of upfront. So, at a minimum, we have environment, service, version. Again, these are going to be our Datadog's reserved tags for unified service tagging. They're going to be responsible for enabling automatic correlation across your infra APM logs. Like I said, again, making it much easier for your SREs to come in, start at metrics, go to logs, all the way to APM without having to kind of remember that context, and instead within the Datadog platform, just use the context switching that we provide. So without these, you're going to lose the magic of the Datadog platform. Beyond the core three, we often see team for ownership and cost attribution. We see application for that business level grouping. Again, these can be as custom as you want, but we typically like to see, at least the three unified service tags, and then team application, and then whatever you need down the road. One note from kind of a technical point is that there are some requirements for tags. So naming conventions matter. I won't go too in depth. There's a lot on our docs, but it must start with a letter. They can be up to 200 characters, and then consistent abbreviations. So we look at the environment tag. Often we see prod, staging, dev. If you're using prod, you don't want someone else to use production or PRD. You want to make sure that you are in fact using that same abbreviation across all your tags there. Second here, we have RBAC. So RBAC is going to be kind of how you decide who can see what within the Datadog platform. So default Datadog roles are typically too broad for enterprise governance. Out of the box, we have standard, read-only, and admin. With standard, you can modify log pipelines, generate metrics, change integrations, all of these things that can actually impact cost or break collections. So to make sure that you're avoiding these issues right off the bat, the solution is going to be creating these custom roles from the start. So for example, we can see org admin for those platform leads. These are going to be the users that have access to everything. They can, be responsible for costs if they need. Everything that can be done within Datadog, give them full access. We can have something like limited standard for developers that lets them work without really accidentally causing damage. And then you have read-only for, say, your stakeholders that really only need to come in, view the dashboards, get the information that they need, and then, get out. So these roles are often overlooked, but remain an important step in creating that successful migration.
All right. And then we get to the foundational deployment. So this will be a few weeks, depending on what approach we take, but the goal here is to deploy the agent and establish standards among them. The key principle here, even with a handful of servers, is to use automation. Manual installation can create configuration drift, inconsistent versions of the agent being applied, missing or misspelled tags, and just general inconsistency that's going to make life a little bit more difficult in the future. Your configuration management tool should be what's handling the deployment. Personally, we typically prefer Ansible, but there's plenty of other options out there: Puppet, Chef, Salt, whatever you're using. Even if it's a PowerShell script that you've written that's dynamic enough to handle the tagging that's required for specific servers and having various tags among them, something that is not a human's hands on keyboard should be fundamentally required during the deployment process. The consistency here is absolutely key, and so is the repeatability, so we can run changes in the future and we can update agent versions, and we have full control over our configuration. For Kubernetes, we do recommend using the built-in resources provided by Datadog. So that comes in the form of a Helm chart or an operator. It's very well documented. It's very straightforward to configure. There's a lot of quick time to value there, and every option for you there is laid out. It's definitely a pick your flavor here. Personally, I prefer the Helm chart. Because I like the values files and how everything is listed out. The operator is also very well documented, but I have an inherent distrust for certain pieces of software that do other things that aren't directly under my control, but that's just me. I've used it regardless. And then with the cloud, you get native integrations that are really just kind of click through within the Datadog UI there. But the approach remains the same. We need to make sure that we are consistently applying our agent integrations with consistent tagging across the board for everything that we are going to be adding into Datadog.
Cool. So next we have the cloud integration setup. So within Datadog, Datadog itself is going to be cloud agnostic, meaning we integrate with all the major cloud providers. So AWS, GCP, OCI, Azure, anything where, the main providers, it's a simple install with our out-of-the-box integration. So these integrations are going to help provide visibility into the managed services. So RDS, Lambda, Azure SQL, GCP Cloud Functions, things where you necessarily can't install the Datadog agent. You can use the out-of-the-box integrations to pull the metrics from those services. For these integrations, setup is going to be straightforward. IAM role for AWS, service principal for Azure, service account for GCP. These integrations will connect to your service and then pull the metrics via the cloud provider API. So a couple things to mention when we're looking at cloud integration setup. First one's going to be configure only the regions and services you actually use. So by default, the integrations are going to pull everything, which means API calls for services returning no data. So those API calls appear on your cloud bill, but not your Datadog bill. So something to keep in mind there. Second, understanding the timing difference. So with agent collected metrics, these are going to be real time. When you're using these cloud integrations, those cloud API metrics have polling intervals, which means there's inherent delay. So for critical workloads, agent-based collection is always preferred. From a Datadog employee, agent-based collection is always going to be preferred for everything. But if you do need to pull these metrics, we offer that opportunity as well.
Yeah, and the cloud integrations are also great for a very quick start of things. If you're in one of those main cloud providers and you can install the integration, that means you can start pulling data down immediately. And any tags that you have on those resources will also be pulled into Datadog. But like Kevin mentioned, it will also give you insights into things that you can't run an agent on, like an RDS instance. You'll be able to get data off of that. You can still run an agent against an RDS instance to pull in like the SQL engine metrics and that sort of thing. But the cloud integration setup, it's always one of the first steps that we recommend if you're in the cloud, because that's going to immediately pull down everything that's in your cloud accounts and start providing immediate value through dashboards and monitor templates that we can just work right through. All right, let's get to phase three. This is going to be our instrumentation strategy for APM. The timeline definitely varies significantly based on the service count and complexity. So it's tough to put a timeline on this. We put 8 to 12 weeks, but it could be very, very quick. If you're running Java applications in Kubernetes and you decide to go with single step instrumentation through the Helm chart, you could have this done in a half an hour. And frankly, if everybody did that, I probably wouldn't have a job. So, let's keep it more complex. No, kidding aside. It's the instrumentation strategy is very important. And we also need to understand that not everything needs APM on day one, and some things just don't need APM. The focus for APM is typically services that communicate with one another or have a high amount of complexity among themselves. So we're talking about a series of microservices that we need to understand the interactions between. That's where APM really truly shines. There's a lot of different pathways that microservices can take, especially once we get into meshes, queues, reverse proxies. All those sorts of things can really complicate observability, and APM helps to solve for that. If you have a monolith that has complicated business logic that's making a lot of kind of self requests and database queries, it's also extremely valuable there. But there's some items that just don't present a ton of value. If you have a batch job that's moving files from one place to another, there's not really anything that APM is going to show you out of the box without additional instrumentation. So always kind of focus on what your most critical business goals are in terms of what's most impactful to prioritize APM instrumentation, and then decide if you need it on certain things in the first place. So that's why we go through this prioritization here, kind of like I was just mentioning. Tier one, the most important stuff, this is customer facing and revenue impacting. Tier two is going to be some things behind the scenes that maybe have some known performance issues or a high frequency of incidents. And then tier 3 and 4 is going to be some of the other accoutrement that we have within our infrastructure. Could be internal tools that we want to make sure our users can use, batch jobs like I just mentioned, but this is where some of the items kind of become questionable in terms of the value that's presented there.
Cool. So when looking at APM instrumentation within Datadog, I like to break it down into kind of two main instrumentation methods. Those being auto instrumentation and then manual instrumentation. So auto instrumentation is going to be the fastest path for supported language and frameworks. So if it is supported and you are able to use auto instrumentation, all it typically takes is installing the tracer library, setting your environment variables, and restarting the application. No code changes for those standard supported frameworks. Secondly, we have the manual SDK. This is going to be when you need to use custom spans, or you have custom business specific attributes, or you're using a framework without automatic support. So this is going to have more control, but requires code changes and a little bit more deployment. So each has their pros and cons. Typically, we see customers using auto instrumentation as it's the fastest route to instrumentation. But like I said, if it's not available to use auto instrumentation, then that manual is another good route. I got a quick question for Nick. Is there anything that you see, is there you favor any of either of these methods, or kind of a case by case?
Yeah, it's definitely case by case, but if I had to pick one, single step is definitely preferable. You do definitely want to be careful when you're rolling this out to make sure that this is single step is supported for all sorts of installations, whether it's just agent-based Docker. But my preference here is when it's in Kubernetes. This allows the people that kind of control the cluster, maybe your SREs or DevOps team, to help deploy APM out to applications without putting the burden of instrumentation on the developers. This is really quick and efficient. All we really need to do is roll out the changes to the agent, make sure that the admission controller is enabled, and then restart the applications that are relevant. And just kind of redeploy your deployment, do a rolling restart, whatever method you have at hand. The trick here is to make sure that you're using the granular configuration for these, that you're specifying particular applications by labels or by namespaces, and only providing the libraries to them that are necessary. Otherwise, the process will kick in where it's going. The Datadog agent will try and determine which language it's running. And in some cases, that can require multiple init containers that delay the startup of your application. So if it's a Java application, define for those label selectors that it's Java, and you restart the applications, and suddenly APM is just there. So it's definitely the fastest way to go about it. It does require a fair bit of planning to make sure that your configuration is correct. But in terms of time to value, single step is fantastic. And then of course everything else typically winds up being auto instrumentation. The manual SDK implementation winds up being a little bit more rare, just because a lot of people find that when we're looking at our typical red metrics, your response, your requests, your errors, and your latency, that you don't necessarily need to understand specific spans through specific business practices like you would have in other platforms. Of course, if you need that, you can certainly have it, but a lot of times the data that comes directly out of the box is more sufficient.
Awesome. Cool. So diving a little bit deeper into the APM data model, you're looking at kind of like, how this applies to the pricing. If you're familiar with our logging product, this will look somewhat familiar. But the idea here is that with Datadog, you decouple ingestion versus indexing. So ingested spans are everything sent to Datadog. These are going to be available for 15 minutes via the live search feature. This can be great for real-time debugging. And then the cost for those is based on that ingestion volume. Now, when you save things, that's going to be the index span. So index spans are what you retain long-term for the historical search. So these are going to be queryable, and they're also billed per span retained. So one important note here, trace metrics are generated from all traces, regardless of whether you index the span or not. So this means full statistical fidelity for dashboards and alerting without actually having to retain every span. Again, this kind of goes back to that cost idea of being able to ingest everything, but only save the things that you want to pay a little bit higher price for that historical search down the road. And then lastly, one other feature is going to be that intelligent retention, which automatically captures a representative sample. So diversity sampling plus 1% flat sampling, and then all error traces by default. So these index spans don't actually count toward your usage. And for most cases, intelligent retention provides what you need for troubleshooting without having those custom retention filters.
Awesome. And then we get into logs. The goal here is to be cost effective with proper tiering to also make sure that you are retaining the value from your logs that you need. This is where some optimization really, really matters. In any platform, logs are typically the largest driver of observability costs. Unlike infrastructure monitoring or synthetic testing, which is relatively predictable, log costs can scale with volume and retention and also changes to production. If somebody accidentally pushes out a log level change to go from warning level to debug, you now have a huge amount of logs on your hand. If somebody adds additional log statements to an application that are in high traffic pathways or in loops, that can be a huge kind of unpredictable increase. So we do want to make sure that we are sending quality data that will actually utilize within the platform. So before collecting any log source, like kind of run it through this framework and think about where we are going to actually store it if we choose to store it. So do I need to alert on this? Do I need this for incident management and real-time debugging? That can go to a standard tier index. Do I need to query this frequently for troubleshooting, maybe a few days after the fact? That can go to standard or it can go to flex after a certain period of time. Do I need to keep these for compliance? Are we under certain restrictions where we need to keep data for certain periods of time? You can send those logs to flex logs for a longer period of time, or archive them out to the cloud where retention is then on your side with retention policies in S3 buckets, for example. And if you have a log that doesn't fit any of these, then just don't index it. There are multiple methods to kind of exclude logs from collection in the first place. But if you don't need that log for any of these purposes, don't send it. We definitely run into a lot of situations where people ask us for help kind of taming their logs, and we come back with questions of, we see these logs are at high volume. What do you use them for? And the answer a lot of times is, well, we don't use them, but we might. And 9 times out of 10, those are never actually used and they just kind of remain in the account. So definitely be deliberate about what you are bringing into the platform in terms of logging. The cost is a huge driver from this, but also, again, signal to noise ratio. If you have tens of thousands of logs in one message that is going to kind of show you what happened, you wind up having to find a needle in a haystack. We would rather just have the problem more apparent through less hay in the pile, we'll say.
Cool. So let's take a quick look at, a typical log indexing strategy that helps balance capability with cost. So at the top here, we're going to have our production applications. These are going to be retained for 15 days. These are going to be your standard logs. that produce, errors, any events within your applications, anything that you'll need to kind of do some, semi deep diving into, we'll keep those for 15 days. Below that, we have our security events. These are going to be the ones that say you get audited a year down the road, you need to be able to go back to the previous year and pull out those security events. We're going to set up an index that keeps these security events retained for 450 days. Debug logs kind of in their own index and with very short retention. For this example, we're keeping them for 3 days. Debug level logging in production shouldn't really be kept for 30 days. So in this case, we're just going to keep them in the platform for 3 days, just in case we need to reference them as we're looking into anything as we're developing the application. And then lastly, we have that catch-all being the flex logs. So a catch-all flex index at the bottom helps capture everything that doesn't really match those specific indexes above, making sure that if you need to, you still have access to them. But this changes, depending on the applications and your environment. This obviously can change, but typically, this is a pretty average indexing strategy that we see often.
Absolutely. And then we start getting into phase 5 here, and this is our operational side of things. So we mentioned earlier on that the service catalog is important. This is how we understand which team owns which service, who's on call, do we have run books and code base links, and do we have the reliability accounted for in terms of monitors and SLOs created for it. This is a centralized developer portal to understand what is running in your infrastructure and all of the information about it. It's a really great source of knowledge, and you can look at a lot of things at a glance and understand what was created in terms of resources against specific services to understand your operational health. It definitely has multiple functionalities depending on how you use it, which is why there's multiple tabs. There's ownership, performance, reliability, and all of those views are tailored to look at those from that perspective. And as we go through the rest of the service catalog and kind of dive deeper into each service, we find that all of the infrastructure that's present is linked to it. And it's just kind of the glue behind your traces, your logs, your synthetics, monitors, dashboards. It really glues everything together in a solidified place. So this will be populated as part of the migration, not afterwards. There are several different ways to populate the service catalog, and including, you can basically use like curl scripts and a CI pipeline that would spit out information about that service, all the way to using Backstage or ServiceNow to populate those definitions automatically. Then we get more into the dashboard strategy. So this is where you start operationalizing everything that you've built. Again, same principle we've talked about multiple times applies. Don't translate, rebuild. The dashboards that you may have been using in the past were likely built for a different data model. What we do want to use is Datadog's capabilities. We want to start with our dashboards that are actually informative. So start with user journeys as an example. What questions does an operator need to answer during an incident? What does the on-call engineer need to see at 3 o'clock? How can we understand which customers are actually affected, where, and why? Each dashboard should really tell a story as best as possible, not just kind of a mishmash of information that was thrown up on a screen. Luckily, you have a lot of help getting this done. The Datadog integrations and cloud integrations and a lot of other portions of Datadog come with out-of-the-box dashboards that are very, very well-designed starting points. Datadog in their documentation will also say that these are templates and they are meant to, be cloned and modified, but they are a fantastic starting point to get some critical views that you need as soon as possible. The other thing that's really important here is think about the one-to-many principle here. A lot of other platforms will kind of push you towards making let's say we have 10 Kubernetes clusters that represent 10 different environments. They would push you towards creating 10 different dashboards, one for each cluster and environment. What we want to do in Datadog is utilize template variables where we have one dashboard instead of 10, but then we have dropdowns for the cluster name and environment. So one dashboard winds up serving multiple contexts where anyone who has need of that information can go to one location without having to question whether it's correct or not, or if they're using an out-of-date dashboard, or if it's missing something. So building that one-to-many principle in a way that also tells a story.
So we look at alert hygiene and kind of where Datadog fits in here and what issue it solves for. Alert hygiene is going to be where these migrations can succeed or fail long term. So what is the core problem? Over alerting is how observability platforms go to die. When people are fatigued by alerts and stop caring, they stop using the platform. So I like to translate this to the boy who cried wolf, right? You have the SRE who gets pinged every morning, 2 a.m., wakes up, oh, I'm getting, alerted on something that doesn't necessarily matter. I'm just going to go back to sleep. Eventually, that issue is going to actually be a real issue, and they're going to go back to sleep, and they're going to, lose money down the road, whatever it may be. So migration is going to be your opportunity to fix this. So you don't want to migrate your broken alerting configurations. Instead, we're going to rebuild it with that hygiene. So every alert should pass some sort of simple test, right? Is it actionable? Can someone do something about it right now? Is it appropriately urgent? Does this indicate a real problem, not just noise? Is there a clear owner? Is there a runbook? If an alert fails any one of these, then we need to either fix it or delete it.
And this is the part where I get on my soapbox. Wanted to make a specific call out following that slide about warning level alerts. This is a very strong opinion that I've had. I think a lot of people disagree with me. But at the end of the day, a warning alert is typically not necessary. There are obviously situations where it is necessary. This is not a kind of blanket statement. However, personally, I believe that warning alerts in 99% of cases should be illegal. The reason for this is that when we have the ability to set a warning threshold, a lot of people will tend to. But when you get a warning is generally inherently not actionable. It's telling you that something might happen, not that it did happen. Now, of course, warnings can be really important in certain situations. We had one come up yesterday where a customer had an HA pair of servers through Pacemaker, and if one of those goes down, then they have a single point of failure. So they should get a warning that tells them that one of their instances is down. That's different. If you have a critical database where you need to know when disk space is approaching the point where it's going to be an issue, you might want to get ahead of that. There are definitely situations for this, but don't create warning alerts for everything because you can. This is the fastest route to alert fatigue. And one of the quickest ways to burn people out from alerts that, they get an email and they think they get an alert. It's actually a warning. Nothing is really going on. Again, just like Kevin said, it's a boy who cried wolf. So avoid warnings unless they are really super important and critical to your business or some of those specific situations that I mentioned. But otherwise, it should just be an alert that is actionable when it is actually actionable. And with that all being said, I step down from my soapbox and we move into Q&A. And we do have a few questions that have popped up. One that comes back to the role-based access control model. We recommended the 4 of admin, SRE level, standard user, and read-only user. The question is about team level isolation and scalability. Let's say we have around 20 different teams. How should access be isolated per team? Should we create 4 roles per team to maintain isolation? Because this would result in 20 teams times 4 roles, meaning 80 roles. Or is the recommended or best practice approach for, is this a recommended approach for role-based access control in Datadog? Or is there a more scalable way to achieve team isolation without managing a large number of roles? So I can answer this one pretty quick because we just went through this with a customer the other day. So roles and role-based access control are very much separate from the team construct within Datadog. So when we're trying to prevent operational changes in the platform through somebody generating a huge amount of metrics through logs or breaking log pipelines and that sort of thing, that's where the role-based access control comes in. So we don't need that at a team level because RBAC at the role level is controlling what a user has access to in the platform. Team-based access control comes in terms of like dashboards, monitors, SLOs, and synthetic tests. So you can put restrictions on individual resources like that where only that team can edit that dashboard or that monitor. Everyone else can still view it, but only that specified team would have access to this. And there's actually some workflow blueprints that are built into the Datadog platform, where you can see you can use them as examples or build off of them yourself, where every night a job will run that will see that, oh, this dashboard is assigned to the storefront team, and it will make sure that there's a restriction in place that only that team can edit or modify that dashboard or alert or whatever resource. So I think in general, my recommendation here would be to keep the roles in the platform relatively broad in sense of, not broad in the sense of access, broad in the sense of there is an SRE role, there is an admin role, there is a limited read role or limited standard role and a read role. Whoever gets access to those is kind of dependent on how your organization runs, but then team level isolation is a resource-based isolation level and would be dependent on some configuration of each resource for each team there. Let's see. We have another question. What Jira integrations do you have built into Datadog? Can tickets be made easily with relevant content such as crash location, crash exception, version, app name, etc.? Yeah, Kevin, do you want to take that one?
Yeah, absolutely. So this is a great question. So what I'll start with, the Jira integration is pretty well built out within Datadog. So it's going to be bi-directional, meaning changes within Datadog are automatically pushed to Jira and vice versa. And when let's say an incident is created inside of Datadog with a monitor, you can automatically create a Jira ticket from Datadog, and then that information that's shared between the two sources is going to be shared back and forth. So that information can kind of be customized as well. So you get a little bit more in-depth information that rather than, monitor A has been alerted. Instead, you can say monitor A has been alerted. Here's the reason why. And then it, becomes easily trackable within the Datadog platform as well as on the Jira side as well.
Yeah, and there's also the integration of Jira with within the error tracking section of Datadog as well. So over time with RUM logs and APM, Datadog will identify error signatures with stack traces, what service they came from, what version of the software was it running, and identify an error signature against those. And there are options within that signature to then submit a ticket to Jira. So you would have all that relevant context information directly in that ticket. You could also create a monitor off of new error tracking events being detected or high impact ones being detected and send those to Jira as well. And that would contain the same information. So there is a lot of, like Kevin mentioned, bi-directional functionality, whether it's incident or case management, error tracking, or a pure monitor that you can use to integrate with Jira back and forth.
So I see one that maybe you can handle here, Nick.
Sure.
So what's a realistic timeline to see ROI after migration? Are we talking months, quarters, etc.?
That's a great question. And it's going to be everyone's favorite two-word answer of it depends. Um, but not really. We should start to see immediate return on investment if we did our planning appropriately. And there's definitely some types of infrastructure that have a much more rapid return on investment than others. If we're running a fully VM-based infrastructure and everything along those lines, and we don't have a ton of automation or we have to develop it, that can definitely take a little bit longer to get the data in there. And without the data, it's hard to have an ROI. However, if we are running, let's say our full infrastructure lives in EKS in AWS, day one, we can get the AWS integration installed and then apply the Helm chart with single step instrumentation for APM and log collection to the cluster. And you can get ROI within a few hours from that. So it will also depend on what like the definition of ROI is. I think if we're talking about pure return on investment being that we saw more value in dollars than we spent in actual cost, that can definitely take a little while because that ROI pretty much comes from when you've successfully resolved your first incident a lot faster than you would have before. However, you can still get a huge amount of value out of the platform quite literally on day one if you go into it with a plan and execute accordingly. I think we've got time for one or two more. Here's a good one that actually comes up really commonly. Kevin, you can take this one. Can you run Datadog agents alongside existing agents from other platforms during the transition, or is there conflict that's caused by that?
Yeah, great question. The answer to that is yes. And that's kind of goes to that point of parallel migration. So, you're not just turning off one agent and turning off or turning on the Datadog agent because it's not really the safest method to go about migration. So, being able to kind of run two simultaneously is a possibility. And, I guess, suggested when we're looking at our best practices for migrations. Um, Anything kind of else you want to add to that, Nick?
Yeah, I think there's one caveat to add to this, and we definitely recommend running things in parallel. Any observability agents at the end of the day are going to be or should be read only. So we're reading file systems for like the proc file system for CPU and memory usage, and we can have a read only file handle on a log file to ship those logs. We can run against the Nginx stats endpoint to get information. We can run SQL logins from multiple places. And really the only overhead there is additional resource consumption on the machine, which even that not super impactful. But the biggest caveat here is when it comes to APM tracing. Um, as much as and I usually say you can in some cases run multiple tracers on a single application. However, you never should. In some cases, you just can't. If you're running .NET on IIS, you can't have more than one CLR profiler, which is how any observability platform does APM. 99% of the time, you physically cannot run more than one tracer. In some languages, you can, but what you're going to wind up with is a much higher overhead on your application because you have two competing languages that are doing instrumentation that may cause performance issues and potential memory leaks. But you're also going to pollute your spans a bit. So when we see HTTP calls leaving your application to reach out to third parties, that would include the other observability provider as a third party. So you'll see aspects of your spans in Datadog that show your application reaching out to other providers, and it makes kind of a polluted mess. So is it possible to run more than one tracer? Yes, sort of, kind of, with a huge asterisk. I generally just say no because it is a really, really bad idea. But if you're talking about reading log files and shipping metric data and everything, yes, it's absolutely possible and encouraged during migrations. Let's see, do we have time for one more? All right, this is kind of a quick one. At what point do you recommend customers just start fresh versus trying to replicate their existing setup? Um, I think, Kevin, you mind if I take this one because I think I have some
Yeah.
opinions about this, but it's kind of a quick one to answer. Um, Replicating your existing setup, like we mentioned, is something that you should never do. You should always rethink it. But there comes also a certain point where if you're coming from one product and you never really expanded besides what's provided to you out of the box from that provider, some providers come with huge monitor packs that just uh, kind of dictate what you're getting and dashboards that are already presented to you and ready to go. At that point, if you're not at all married to those, just start fresh and do it the Datadog way. There's really no reason to do that. Or in some cases, if you realize that you're under mountains of tech debt and your organization is huge and nobody knows what's being used, nobody can answer the questions and everything. I would often encourage the kind of scream test of we're just moving everything over, we're starting fresh, we're completely rethinking everything. And especially if you're running in parallel over a longer period of time, if it turns out that you need to recreate one of those dashboards or monitors from the other platform, you certainly can. But I would usually advocate for starting fresh more frequently than not. All right.
All right, great. Thank you, Kevin and Nick. That was a great Q&A. So guys, everybody, thank you for joining us today. And to wrap things up, the main takeaway we want to leave you with is that a successful Datadog migration really comes down to getting clarity early on. And so our migration scoping engagement is a focused way to do just that. It'll really help you understand your current environment, design the right tagging strategy, and map a migration plan that avoids any rework or surprises that might come up later on. So if today's session was helpful or raised questions, our contact info is here on the slide, and we'll follow up with the recording, the slides, and a few other resources Thanks again, everybody, for spending time with us today. Hope you enjoy the rest of your day.
Thanks, everyone.
Thanks, everyone.